Let's take a look at inconsistent dependent equations by matrices on a TI-89 calculator. Let me show my website. This is www.mathheals.com. You can find more links to YouTube videos on this site. If you go to graphing calculators and then go to college algebra, you'll see all the different topics that you can use the graphing calculator on, and different models of the calculator. And I'm working my way through all the subjects and all the calculators, so you'll see those eventually appear. Also, under math class information, though I'll eventually rename that to math lectures, if we click there, go into college algebra. Here you can find full lecture videos on various topics in college algebra, and click the YouTube video link. These are the exact same lectures I give in the classroom, same explanations, same examples. It's not watered down at all. Don't click on the WebEx. I'll eventually remove those. That was before I knew how to do YouTube. Okay, I'm done with my sales pitch. Let's take a look at this inconsistent dependent equations. So let's take a look at our first one. Okay, we got 3x plus y plus z is equal to 2, and 4x minus 2y minus 5z is equal to 1, and 6x plus 2y plus 2z is equal to 4. Let me double check all those numbers. Well, that's good. Okay, we're going to write down the matrix that goes along with this. We drop the x's, y's, z's, and equals, keep the numbers in their signs. So we've got 3, 1, 1, 2, 4, negative 2, negative 5, 1, 6, 2, 2, 4. Well, let's go input this matrix in. Okay, so I'm going to go to my apps, and you see number 6 is data matrix editor, so I choose 6, the numbers in front of it, and I'm going to show you new, but I need to do open because I think I already have A. But if I choose new, if I do 3, then you see the type says data. If I right arrow, it'll pop up this list, and I can choose 2 for matrix. Now down arrow, and down arrow again to get down to the variable, and I want to choose A. So I think the alpha lock's already on, so I can do an equals and see how it puts A there. And now if I do a down arrow, it's asking me for the size of my matrix. This is the number of rows. Well, we got 3 rows here. Now I think my alpha lock is already on, so if I do a 3 now, I think it'll put an S there. Yeah, I did. So let me do a backspace. You shut off the alpha by pressing alpha 1 time, and now put 3 there. A down arrow to columns, and we have 4 columns here. So do 4, then press enter, and then I'll press enter again, and it'll create the matrix for me. Now I can't see everything on here, but that's okay. It'll automatically scroll over. I'll type in each number pressing enter. So do 3 enter, 1 enter, 1 enter. Notice it scrolled over to column 4. Then 2 enter, 4 enter, negative 2 enter, negative 5 enter, 1 enter, 6 enter, 2 enter, 2 enter, 4 enter. Let me double check my numbers. 2, 1, 4, 1, negative 5, 2, 1, negative 2, 2, 3, 4, 6. Very primitive spreadsheet. You can use your arrow keys to scroll over. Now, you notice that that worked just fine. So now I'm going to exit out. So I'm going to do second escape. I didn't know whether to remember what variables I had from the previous time I ran this. But sometimes, if you already have the matrix created, if you go into your apps, and you go into your data matrix editor, I do 6, and I do new, and choose right arrow and then choose matrix, down arrow here, and I put in A, down arrow, hit the alpha to shut it off, and if I put in let's see, 3 rows, down arrow, put 4, down arrow, and then press enter. Gives me an error. It says variable flash application in use. Escape to cancel. I hit escape again. We already have created this. We already put it into A. So if you already have one created, you can't do a new on that name, which is what I was thinking might happen the first time. To open up an existing one, let me show that just in case you have this whatever matrix already created on your calculator. If you press apps, you go into 6, and then you choose 2 for open. And there's a type, it says data. You can right arrow and change it to matrix, so you do 2 for matrix. Now, if I down arrow to variable, see it already has A here. That doesn't mean that's that it knows which one I wanted, but if I do my right arrow key, it'll come up with a list of all the ones you've created. And I only got A, so that's all I got. And then if you press enter and then enter again, it'll bring up that matrix. So that's how you can bring up an existing one to change it. And again, to exit out, you just do second escape to quit. Okay, now we want to do RREF on this and see what we get. Well, I'm going to go to my math, so do second 5. That'll bring up a math menu, and you see I got a matrix. If I press 4, the number in front of it, I'll come up with this, and I want to choose the RREF, the 4th one. So I press 4, the number in front of it, or you can down arrow do it and press enter on it. Now I need to tell it RREF of what, and we put our matrix in A, so I can just do an alpha equals to get A, and then I'll put a closing parentheses, and then press enter. Okay, now what we get is 1, 0, negative 3/10, and 1/2, 0, 1, 19/10, 1/2, and 0, 0, 0, 0. Okay, we got 3 equations and 3 variables. So our first 3 by 3 square here should be a diagonal 1s, 0s, everywhere else. If it isn't, that means that RREF did not work. RREF stands for reduced row echelon form. So again, we don't see our diagonal 1s, 0s, everywhere else, so it didn't work. Now the last row is all zeros. This means these are dependent equations. So dependent equations, which means that there's infinite number of solutions. Now some books have you do this different ways. Some may actually just have you specify as dependent equations. And again, the last row of all zeros tells you that. Or they could just have you write infinite solutions. Some books will have you put the variables back in. Excuse me. It was coming. I just was waiting for it. Okay, so this we'll put our variables back in. There's our x, there's our y, there's our z, and there's our equals. Here's our x, here's our y, here's our z, and here's our equals. You don't need to worry about the last row because it's all zeros. So looking at my first row here, I got 1x or x. Now 0y drops away, minus 3/10 z is equal to 1/2. My second row, the 0x drops away, 1y is y, plus 19/10 z is equal to 1/2. Well, this came off of our first row, so I'll solve for our first variable, which is x. So I'll take negative 3/10 z over, and we get x is equal to positive 3/10 z plus 1/2. Now this one came off of our second row, so I'll solve for our second variable, which is y. Take the 19/10 z over, it becomes a negative 19/10 z plus 1/2. Now the form of our answer is x comma y comma z. Well, we now know what x and y are, so I can plug those in. X is 3/10 z plus 1/2, comma y is negative 19/10 z plus 1/2, and z is just z. Now typically you put another variable in there for z. You have this set up here, you put like t in or a or s or something. I'll put t in. So we got 3/10 t plus 1/2 And then we got comma, negative 19/10 t plus 1/2. And then over here we just got t. Dependent. Why do they call it dependent? Well, our last variable here, where the z was, we can put anything in there. I can put 3 in here. Now, after I put 3 in here for t, then I would also have to put 3 here and 3 here, so these two are dependent upon z. This would be our answer. Okay, let's look at our second problem. This is the other oddball case. We got x plus y minus 3z is equal to 4. 7x minus y plus 2z is equal to negative 1. And 3x plus 3y minus 9z is equal to a positive 1. Just double checking all my numbers. There we go. Okay, so I got 1, 1, negative 3, 4, 7, negative 1, 2, negative 1, 3, 3, negative 9, and 1. Okay, now I'm going to go enter this in my calculator. Now I'm going to go into my apps button. I want to choose my data matrix editor, so I do the 6 in front of it. I want to choose open because I already have an A defined, don't I? So I'll do a 2, the numbers in front of the open. And I'll right arrow, bring up that menu, and I'll choose 2 for matrix. Now notice this already says A, so that's fine. If I press enter, it'll bring up the existing one. Now I could go into utilities or resize it if I wanted to. We won't because this is already the right size, but if I did second F1, see there's a resize matrix. I'll do escape to get rid of that menu. Anyway, I just want to enter my numbers in. So I do 1, enter, 1, enter, negative 3, enter, 4, enter, 7, negative 1, 2, negative 1, 3, 3, negative 9, and 1. Let me double check my numbers. 4, negative 1, 1, negative 3, 2, negative 9, 1, negative 1, 3, 1, 7, 3. Okay, I want to exit out, so I'll do second escape. And I'll do a clear on that. That happens when I Alt-Tab away from the calculator. Okay, so I want to go in my matrix under the math. So I do second 5. Choose 5 or 4 for matrix, sorry. I want to choose REF again, so I do 4. Now I need to tell it of what? And we put ours in A, so I do alpha equals to get A. Close parentheses, enter. Okay, so let me write down what we came up with. So we got 1, 0, negative 1/8, 1, 0, negative 1/8, 0. 0, 1, negative 23 over 8. I think that was 0. Yeah. And 0, 0, 0, 1. Okay, we had 3 equations, 3 variables. So our first 3 by 3 should be a diagonal 1, 0, 0, or else. Which it isn't. I don't got a diagonal 1, 0, 0, or else. Specifically, the last row is all zeros and a single 1. If your last row is all zeros and a single 1s, it means it didn't work. Specifically, this is an inconsistent system. I don't really like that term, though. I like the term that there's no solution. That's what that means. This particular section here, particular lecture, deals with the oddball cases. And we have our first one, which is dependent equations, infinite solutions, where you have to go through those steps. And then you have our second one here, where your last row is all zeros and single 1, and automatically it's a no solution. Now that's solving inconsistent dependent equations on a TI-89 calculator.